Next speaker is Taniguchi-san. The title is Constructive Approach to the Interaction Between Symbol Emergence and Qualia Structure.
So good morning. Thank you very much for inviting me to this great symposium. So, and okay, my title is Constructive Approach to the Interaction Between Symbol Emergence and Qualia Structure. So the Saji-san's talk is a very great introduction about the interdependency between the language and the Qualia, and also the kind arbitrariness of language system. So the language can make a kind of very different categories on the perception, and also of course that can give different signs to the some categories. Okay, so and it's also important topic of my talk, but based on the Saji-san's talk, I will more focus on the constructive approach part. So I'm Tadahiro Taniguchi from Qualia University, and I published several books. And actually, some of you may know that I have been studying the symbol emergence in robotics. So these are the kind of examples of our experiment. This is about special concept acquisition and lexical acquisition based on the multimodal information by a mobile robot. So the robot is move around the corridor, in the building, and look at get the visual information. And sometimes the user or participants tell the robot, "Oh, you are walking on corridor and you are visiting an elevator hall," or something like that. At first, the robot did not have any lexical knowledge, but by parsing, by segmenting the input voice and correlate, associate that with multimodal information, they form a kind of category of spaces. And this is about object categorization, multimodal object categorization stuff. And I will talk about this later. And this is imitation learning and the world model-based approach, and that's application to the service robot environment. But today, I would say, oh, okay, so this is a kind of robotic studies, but my main interest is not about creating a great robot and useful robot. I'm very much interested in the understanding of the human kind of mental development and developmental cognitive systems that actually acquire language and actually acquire many perceptual skills and action skills and so on, like children, you know. So to understand such kind of phenomena, one scientific way is to create a system that can reproduce such kind of phenomena. That's constructive approach. Okay. So today I will not talk about the robotics stuff, but about symbol and language and maybe Qualia. So I'm very much interested in the communication, semiotic communication. I will talk about the symbol and the semiotic communication, but basically you can consider them as a kind of language or linguistic communication. Okay, so when we use a symbol or sign or language, we say something. But basically, we cannot understand what you are exactly talking about. We cannot inspect your brain spaces, your Qualia. So maybe without such kind of feedback, we should share the language understanding, what this word means. So maybe listener need to infer, estimate what she is talking about. And interestingly, even when we introduce a robot, artificial agent, that's the same. So if there is a Pepper robot here, Pepper says something, but we are always anxious about, is he really understanding what he is meaning? So that's the problem. And also when we introduce a robot, a service robot. So it's also same. Service robot should understand what we are talking about. So sharing the semantic meaning of language is very, very much interesting and kind of still a mystery of this kind of stuff. So because the sign and the categories as a symbol have arbitrariness. So, and generally speaking, we need to think about the symbol. So symbol is a kind of a general, generalization of language. So basically language, when we talk about the language, it's about Japanese, Chinese, kind of natural language that should have syntax and many complex systems. But we also use sign language and traffic signals and many kind of symbols that represent something. So, and what symbol? So, how to say, in daily conversation, we tend to naively assume symbol is a dyadic relationship. So symbol is just a pair of reference and referent, signifier and signified. But that's not true. And especially in Persian semiotics, Charles Sanders Peirce, he's also a pioneer of pragmatism. He defined the symbol as a triadic relationship. It's very much important. This symbol is a triadic relationship of sign, object, and interpretant. What is interpretant? Maybe you can understand what is sign and what is object. Sign is, for example, just an audio signal, up or something, audio signal or written letter or something like that. And the object is a target object. So interpretant is a kind of the mental activity or some phenomena that mediate sign and object. So if the interpretant can change, the relationship between sign and object can change. Actually, this means symbol is not just a kind of object, but a kind of mental process, dynamic phenomena. That is very much important. And so that causes many interesting phenomena. So Saji-san was told about color words and that meaning, the arbitrariness around that. So this is a very interesting example. This is our single blue signal, okay? But this color is green. The green signal is blue signal in Japanese. Green is blue. So it's very much confusing. But and this is the cultural effect can affect the interpreter in the Japanese speakers brain system. Yeah. So and we should consider that the color's name is just a sign. It's not a category, concept, or symbol. So, when we think about the relationship between the language and Qualia or this kind of internal representation, do not assume that there is a true category of blue objectively. The meaning of blue changes depending on context and the situation. It's very important, I think. And I want to mention one thing. Actually, some of you may come from the AI or cognitive science field. So in the AI and cognitive science, the term symbol is a bit confusing because some of you may know the symbol grounding problem. So symbol grounding problem is proposed 1990 by Stephen Hannard. So, but in that context, symbol is from the symbolic logic, basically. This is a historical, there is a historical reason. So in 20th century, AI is very much affected by the symbolic logic. Computer science itself is very much affected by symbolic logic. So that gave us, our community, the idea that the human mental system is based on such kind of symbolic logic like a system. So symbol grounding problem, and such symbol is something like variables in predicate logic. So that is basically nothing to do with this idea of symbol. So language is this kind of stuff. And when we think about the interdependency between language and Qualia, this kind of stuff is more important, I think. Okay, so based on this kind of definition of symbol, I proposed about 10 years ago, I proposed the idea of symbol emergence system. So where the arbitrariness, in what way we human society can solve the arbitrariness problem of symbol. So, okay, this is a kind of a diagram, descriptive, diagram model. And first, children perform as children interact with its environment and observing many stuff, interacting with major object, they form some sort of internal representations. So maybe this can be called in another way. So in the terminology of modern AI, this can be regarded as a representation learning. So maybe I think that this is a kind of mental activation, activation of brain, and this may be same as Qualia. And maybe based on such kind of perception, so the children can can give names to something. But there is another arbitrariness of sign. So if we call this is how to say bonbon or something, bonbon or black blade or something like that. I don't know. So if I say, Saido-san, please take me that black blade. Oh, which one? So, but if we are close friend, and Saido-san also know this is a black blade. So Saigo-san take it to me. So we can invent signs very easily, and the community allows that. So share such kind of sign. So that can be a sign, symbol, okay? So, but everybody should agree with such kind of Chunibyo-like naming, okay? So anyway, so such kind of negotiation can solve the arbitrariness problem. But gradually, this kind of shared idea emerge. So I mean the symbol system can be shared among the community in a bottom-up manner. And as far as we follow such kind of symbol system, we can communicate using a symbol system or language. But this is a kind of constraints, you know. So language system will give you some sort of arbitrary difference system of differences. For that is very much related to the Saji-san's talk. So different language system have different categories, you know. So, but if you resist to such kind of differences, you cannot make use of the benefit of language. So this is kind of top-down constraints. And but if you accept such kind of the constraints, you can make use of language. The important thing is that there is a kind of micro-macro loop here, and also the even language is giving you a top-down constraint, but the language itself is organized in a bottom-up manner, ultimately. Okay, so when we grasp the symbol emergence system in that way, we have two different research target. One is about the representation learning by individuals and symbol emergence by group of agents. So we have been tackling with these. Okay, the first I will quickly mention talk about the representation learning by individuals. Maybe I showed this video before. That in this video, the robot grasps an object and obtained the haptic information and shook it to obtain auditory information and looked at it to obtain visual information. So by combining this multimodal information together with the linguistic instruction that is given as a speech signal. So by integrating that with the probabilistic generative model, multimodal probabilistic generative model, the robot could form these object categories in an unsupervised manner. And also, I will skip that detail. Also, the robot can find the word category, can discover words from speech signal and associate them with the multimodal data and obtain the category and its sign in some sense. So that can be used for further tasks. And interestingly, this model is doing, what the model did is just prediction. I mean, the modeling the joint distribution of sensor inputs. So this is resonating with the recent idea of free energy principle and the predictive coding and world models and so on. So basically, what this system is doing is that to predict the observation, to predict observations, and in inverse way, in opposite way. So by inferring the latent variable with given observation, the system can estimate the category of latent variables. This is the perception process. Okay, so actually next to this kind of stuff. So actually recently we found that this kind of generative view can be extended to the symbol emergence in society. So let me talk about something. So, okay, so we developed a new kind of language game. So Metropolis Hastings naming game. In study of language evolution or emergent communication in AI field, many kinds of naming game was developed. But we introduced a new one. So outline of this naming game is very simple. The naming game consists of four phases. First, perception. And speaker and listener agents observe an object and infer their internal representations. And we assume the joint attention. I mean, they know they are looking at the same object. Next, speaker tells a name of object probabilistically based on their belief. And the listener determines if it accepts the naming with a certain probability, depending on its belief state, kind of the internal representation states, based on Qualia. After the communication is performed, the listener updates its internal parameters for representation learning and naming. So just an update. Then speaker and the listener alternate their role and go back to one. So this looks very natural, okay? And the interesting point is sometimes the listener does not believe what the speaker says. So in this game, if the acceptance decision is made with the probability, this one, with a certain probability, we could show that we can show that the naming game is equivalent to metaphorical hasting algorithm of this graphical model. So maybe that requires so maybe I need to skip the detail, but this model, this graphical model is equivalent to the multimodal representation learning system, like a multimodal VAE. And usually this model represents a single agent. Single agent have two modality and try to combine the two kinds of information, for example, visual information or haptic information, and combine them and form internal integrative representation. So that when we show this kind of graphical model, we implicitly assume this model is owned by a single agent. So, but in this case, OA, this variable represents the agent A's visual information, for example. This variable represents the agent B's visual information. So if the agent want to integrate such kind of information, so their brain should be connected in some sense. So if there is a kind of the brain that can directly observe the two agents' visual information, this kind of multimodal categorization can be performed. But how to say? Usually, if they were humans, that cannot be performed. So, but mathematically, that can be decomposed. And if we introduce some trick, so even though they are separated, the WD, this latent variable, can be inferred. So actually, what we showed is that this kind of naming game can infer the latent variable WD in the same way as this kind of connected brain setting. Mutuality, what do you mean? Very important point. And mathematically, it's not important. It's not important. But how to say, in more detail, the target of the convergence point is same, but the speed will be improved, I think. Okay. So we conducted a simple experiment on the MNIST dataset. So this is a very simple one. The agent A observes the MNIST data. And agent B observed the kind of rotated MNIST data, a bit different one. 4.445 degrees rotated data was given to the agent B. So actually, so I will skip the detail, but agents playing the Metropolis Hastings naming game could form the categories and the shared signs. So, and also important point in this community is this point. So let's look at the difference between the MH naming game condition and the no communication. In non-communication setting, they are separated and they have no communication. And each agent observes different observations and try to form categories independently. So the MH naming game case, they have communication, but without any teacher signal and ground truth level. But the category clustering performance is improved. I mean, if they play the Metropolis Hastings naming game and try to create a category in a collaborative manner, the clustering performance was improved. So this is very much important point. And also we can look into the internal representations, kind of the distributed representation inside of the brain. So actually the the internal representation with symbol emergence and without symbol emergence became different. So symbol emergence is not only for emergent communication, but also for better representation learning. We found that, and we can extend this idea, and this leads us to further hypothesis that a symbol emergence may be a phenomenon with which people perform the predictive coding collectively in a decentralized manner. Maybe we form language, we develop language through a collective representation learning. So that's the hypothesis now I have. And of course, the language system may affect the everybody's internal representation. Okay, so before I get into the research questions of the kind of the next project, I will mention, let me mention one thing about the current development of AI technology. Many of you may know that recently large-scale language model is attracting attention. That is absolutely great. And transformer-based model like a BART and GPT-3 and Lambda and so on have been developed. And this is actually great. And but why so large-scale language model is so great? So this is based on the nature of language itself. So there is the language has the distributional semantics. So even without any perceptual information, the language has the sequences of words, the data set of language sentences, it has involves the information of semantics. So language itself has syntactic semantic latent structure, which are embedded in sentences in a distributed manner. So if the large language model, black braid. large language model can encode can discover such kind of latent structure from the language data that can find the relative relationship between word and sentences in a yeah. So the another discussion point is how the distributional semantics affect the internal representation formation, in other words, Qualia. So it's also important question. Okay, so let me conclude this talk. And actually, the invited by Tsuchiya-san, and I and Saji-san joined this community and submitted research proposal. Let me introduce the important point of our group's proposal. The main question is, does symbol emergence coordinate Qualia structure with others? And does the distributional semantics of language affect the Qualia structure? This is the question. And in the process, through the discussion with the great members of this community, I made up some bold hypotheses that humans may create language in order to match Qualia structures with others and to understand each other. I think this is a kind of very much attractive statement, I think. So the proposal involves 4 objectives, elucidates the interdependence of symbol emergence Qualia structure, and the realization of academic fusion between the brain science and the constructive approach, and the realization of academic fusion between the brain science and the same one? Sorry. Sorry. This part is elucidate. Let's elucidate the Qualia structure affected by language, and innovation in understanding the cognitive development of symbol emergence and Qualia. Yeah. That's all. Thank you very much.